afternoon or early afternoon or good noon, because it's 11:27 on this Tuesday, April 30th. We're solving quadratic equations. We're going to be given in different forms. We're going to be asked to solve it in different techniques, using different techniques. Right at the moment, they want to solve each equation by factoring, so they want you to factor it and then use the zero property. We have two numbers that are multiplying that equals zero. So we know that if we multiply two numbers that equals zero, one of these numbers, one must be zero. One of these boxes must equal zero when simplified. So the question we ask is, what value for p would make this box equal to zero? And yes, mental math, we can see it, but the way that we do it mathematically, at least the way we notate it and show our work, is we set each of those boxes, I call them boxes, groups, parentheses, quantities, I set them equal to zero because we're saying, hey, what value for p would equal, make that left side equal to, or that right side equal to zero. So we subtract 7, we get p equals -7, we add 6, we get p equals 6. So my solutions are going to be -7 and 6. If I plug those back in, that would make the left side equal to 0. Those would be the two values that would make the left side equal to the right side. So we again, n minus 2 equals 0. We'll set the other quantity equal to 0. We'll add 2. Add 2. N equals 2. We'll add 6. N equals 6. So my solutions are 2 and 6. Yes, I know. In the answer key, they did not put them in numerical order. Let me help you. It should be in numerical order. That's the common sense. That's so everybody has the same answer. So if somebody doesn't have 6,2 and another student have 2, 6, we, much like orders of operations, we've all agreed that when we have our solutions, we're going to put them in numerical order. So when we look at it, everybody's looks identical. Here we go. This one is a little bit trickier because we have 3 things, but we notice that that one isn't a variable, so it's not open to being any other value, any value other than 7. That's a constant. So that's never going to equal 0, so that's not up for discussion. But the 0, the value, or the 0 can come from this box, and it can come from this box because it has a variable. It will affect the overall outcome. So we'll add 7. 4m equals 7 divided by 4 divided by 4m equals 7/4. Plus 6 m equals 6. We get 7/4, which is smaller than 6. So that would come first. We have 3 can't be 0. That's a constant. That's not where my 0 is coming from. And we have x minus 8 equaling 0. We'll add 6, x equals 6, add 8, x equals 8. 100. Nice job. Awesome job. It's always nice to tell a student that they got 100 on their test. Yes. Very, very good. So those are the two solutions. 6 and 8 would make that left side equal to the right side. Number 5, so now they are not factored. So we have to factor that. We are going to first, this is our new first, set equal to 0. We must make sure that our equation is equal to 0. Because if it's not equal to 0, then we can't use the 0 property. Then standard form, is the left side in standard form? Is there a common factor? No. Is it a special case? No. 56 is not a perfect square, so we know it's not either a binomial square or the difference of squares. So we will do a times c. A is 1, c is 56. 1 and 56, 2 and 28, 3 no, 4, yes, 4 and 14, 5 no, 6, nope, 7, yes, 7 and 8. The signs are the same. Positive means signs are the same. And we look here, and they're both negative. So negative, 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 negative. Negative 57, negative 30, negative 18, negative 15. Which one's equal to my middle? My middle value is negative 15. This is equal to my middle, so I'm going to pull out these as my outside and inside terms. So this now becomes m squared minus 7m minus 8m plus 56 equals 0. Notice that negative 7m and negative 8m equal my negative 15. I haven't rewritten it, or I haven't created a new equation. I've just broken it from 3 terms to 4 terms. So we're going to group the first two, group the second two by factor by grouping, and we will look what is the common factor between m squared and negative 7m. We can factor out an m. That leaves us with m minus 7. We look at our second group, negative 8m plus 56. We can factor out a negative 8 since our first term is negative. We must factor out a negative. And if we factor out a negative 8, we get m minus 7 equals 0. We did it correctly because we have m minus 7 in both of these. These must be the same. And if we pull that out, we're left with m minus 8. Notice the m minus 8. That's how we got that. And now we have 2 unknowns equaling 0. So we take that box, m minus 7 equals 0. M minus 8 equals 0. We'll add 7 to both sides. We get m equals 7. That's one solution. We'll add 8 to the other side. M equals 8. So my 2 solutions are 7 and 8. Love it. Look at all that. So we go through the same process. We do 1. Is it set equal to 0? Yes, it is. Is it in standard form? Yes. Is there a common factor? Nope. Is it a special case? Set equals 0. Okay, yep. Special case? No. 40 is not a perfect square. So we're going to do a times c. A is 1, c is 40. Factors of 40 are 1 and 40, 2 and 20, 3 no, 4, and 10, 5 yes, and 8, and that's it. Signs are the same. Both are negative. That's negative 41. That's negative 22. This is negative 14. This is negative 13. My middle is negative 13, so I'm going to take negative 5 and negative 8. K squared minus 5k minus 8k plus 40 equals 0. We're going to factor the first 2. We'll factor out a k. You get k minus 5. We'll factor out a negative 8. We get k minus 5. K minus 5 times the quantity k minus 8 must equal 0. Set each one equal to 0. K minus 5 equals 0. K minus 8 equals 0. We'll add 5. We get k equals 5. We'll add 8. K equals 8. And my solution are 5 and 8. Notice 1 set equal to 0. So we have to add 2. We get a squared minus a minus 20 equals 0. That's good. 2, is it in standard form? Yes. 3, common factor? No. Special case? No. 20 is not a perfect square, so let's do a times c. A is 1, c is negative 20. 1 and 20, 2 and 10, 3 no, 4 and 5. Signs are different. Negative means signs are different. And we know that the bigger is going to get the negative. The bigger of the two factor pairs will get the negative. And since the signs are different, the other side has to be positive. Whoa, that's a bad 8. And -1, which one's equal to my middle? -1. So I'm going to take these two factor pairs, yeah. A squared plus 4a minus 5a minus 20 equals 0. We're going to factor out an a, you get a plus 4. Factor out a -5, you get a plus 4 equals 0. A plus 4, a minus 5 equals 0. Let's set them equal. A plus 4 equals 0. A minus 5 equals 0. Minus 4. Add 5. So my solution set is -4 and 5. Yeah. Let's separate that. 1 is set equal to 0. Let's add 8 to both sides. X squared plus 5x minus 24 equals 0. Standard form, yes. Common factor, no. Special case, 24 is not a perfect square. A times C. 1 times -24 is -24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are different. Negative means signs different, and the bigger is positive. So positive, 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 negative, 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 negative. 23, 10, 5, 2. Which one? 5 is my middle, so -3 and +8. X squared minus 3x plus 8x minus 24 equals 0. Factor out an x, you get x minus 3. Factor out an 8, you get x minus 3. X minus 3, x plus 8 equals 0. Set them both. X minus 3 equals 0. X plus 8 equals 0. We're just finding the value for x that would make that box 0. Add 3 minus 8. My solutions are -8 and 3. Solve each equation, you must take the square root. So we are going to take this, we're going to isolate the squared variable. First, got to isolate it first. So it's isolated, so we're going to take the square root of both sides because that's what gets rid of a square. And when we take the square root of a variable being squared, we need to introduce a plus minus sign. That's an important thing to remember. So the square and the square root, they cancel each other. That leaves us with v equals plus or minus square root of 25 is a perfect square. 5, so my solution set is plus minus 5. My variable, oh, look at that. Second problem, Mr. Mac. V squared equals -94. We are going to take the square root of -94. Square and square root cancel. However, cannot take the square root of a negative number. So the answer is no solution. Whoa, no solution. Almost ran out of space there. No solution is the answer. Later on in Algebra 2, you will learn how to deal with negatives in radicals with imaginary imaginary numbers, and you'll have a different answer that will involve the letter I, which is a symbol representing the square root of -1. But we won't do that. So let's isolate the variable. This time we're going to move our constants to the other side. We're not looking to make 0. This time we want to isolate the variable because there's only one. We didn't isolate the variable here or here because we had two different variables. We had a squared and a, so we were never going to be able to isolate the a. The only way we could do that would be through that isolating, through factoring and using the 0 property. So here, the advantage of this is we only have one variable. It's being squared, so we isolate it. So we'll take the square root. Whenever you take the square root of a variable being squared, we do plus or minus. Square root and square cancel, leave us with v equals plus or minus. Now, 72 is not a perfect square, so I'm going to break it down, and I want to find a perfect square factor in 72. Yeah, you can break it into rad 8, rad 9, because 9's a perfect square. However, that can be still broken down, so that might not be the best. You might want to find 36 and 2, and then we can break up. You can break up radicals being multiplied. Why did I pick 36? Because 36 is a perfect square. So square root of 36 is 6. Rad 2 can't be simplified, so my answer is plus or minus 6 rad 2. Now you would have gotten there also if you had broken it into rad 4, rad 2, and that is also a perfect square, and you would have gotten 2 times 3 times rad 2, which still gives you plus or minus rad 6, or 6 rad 2. So let's isolate by dividing by 16. We get k squared equals 1. We'll take the square root. Square root of k squared is k. Plus or minus square root of 1 is 1. So my answer is plus or minus 1. That's a fun one. Let's get rid of, we're isolating. So negative 9v squared equals negative 729. Divide by negative 9. Gives me v squared equals positive 81. We'll take the square root. And we get v equals plus or minus 9. So plus minus 9 would be the answer there. Let's add 4. 6k squared equals 204. Divide by 6. You get k squared equals, well, we know, does that go in? Oh, yeah. 18 goes in 3 and 2. So 34? Is that 34? 34. Yeah, I think that's right. Let's check it. 204 divided by 6, 34. Good. Now we take the square root of both sides. We get k equals plus or minus 34. What are we going to break that down into? Well, factors of 34 are 1 and 34. That doesn't help us. 2 and 17. That doesn't help us. So that is just simplified. So, well, not 36. We would love it if it was 34. So my answer is plus or minus rad 34. Cannot be simplified, which happens. All right, now you must complete the square. I love this. So when completing the square, we move the constant over. We get b squared minus 10b equals 56. Now a needs to be 1. A is the coefficient of b squared, so a must be 1 when completing the square. So we're going to take half of my b value. We're going to take half of that. Negative 10 divided by 2 is negative 5. And then we're going to square it, and we get 25. So we're going to add 25 to both sides. And because we added 25, this now is a binomial square. That's what we produced. The reason we like that is because that's going to produce b minus 5 quantity squared. Where we get the minus from this sign, that's always going to have its sign, equals so 81. And now we have a quantity squared. So we take the square root of b minus 5 quantity squared, because that's what's going to get rid of that square, plus or minus square root of 81. This produces b minus 5, because the radical and the square will cancel each other. We get plus or minus 9, and now we solve. We're going to isolate b, and we write b equals 5 plus or minus 9. I always like to write it that way. I think that it's easier to get your answer. So that's 5 plus 9 and 5 minus 9. That gives you 14. This gives you 4. So my solution is 4 and 14. Those are the two numbers, when plugged in, are your solutions. Same thing. Let's move my constant over. You get x squared plus 14x equals 15. Make sure my a value is 1. We're going to take half of 14 and square it, so 49. So we'll add 49 to both sides. We have to balance the equation. You just can't put a 49 on the left there. And now we know that this is x plus 7. That's half of your b value is how you get that. And then you get, what's that, 64? Yep. And now we'll take the square root of both sides in order to get rid of that square. When we take the square root of a variable being squared, we introduce plus or minus. You get x plus 7 equals plus or minus 8. Let's minus 7 from both sides. X equals negative 7 plus or minus 8. Let's write out both of those situations. Negative 7 plus 8, negative 7 minus 8. That's 1, that's negative 15, and we write them in numerical order. Let's add my constant over. You get n squared minus 7n equals 60. So notice my b value now is an odd number, and so that's going to be a little bit more challenging. You get a weirder value. Doesn't mean that it can't be done. Doesn't mean that you can't handle it. Fractions are fine. This is the easy part. You know that this is n minus 7 over 2, quantity squared. It's just half your b value. And then this is where it kind of gets fun. So 60 in fourths, that's, no, let's not do it in black, let's do it in blue. That's 240 over 4. That simplifies to 60. So you get 200. Let's move this down just a wee bit. So 240 plus 49 is 289 over 4. And now we'll take the square root of both sides, n minus 7 halves, quantity squared, yeah, that's right, equals plus or minus rad 289 over 4. You get n minus 7 halves, because the square and the square root cancel, equal. Now we can separate those into their own radicals. And you get n minus 7 halves equals plus minus 289. What's that, 13? 13? No. I'm going to say 17. 17 squared, 289. 17 over 2. And now we're going to move, we're going to isolate our variable by adding 7 halves to both sides. You get n equals 7 halves plus or minus 17 halves. So that's a fun one. You get 7 halves plus 17 halves, and you get 7 halves minus 17 halves. That's going to give us 24 halves, which is 12. This will give us negative 10 halves, which is negative 5. Nice, clean, happy numbers, and that worked out nicely. We're going to add 70 to both sides. You get n squared minus 9n equals 70. We're going to take half of our b value and square it, which gives us 81 fourths. So we're going to add 81 fourths, add 81 fourths. This becomes n minus 9 halves squared equals, well, let's move that down again. That's how many fourths is 70? That's 280 fourths. So that gives us 361 fourths. Is that right? 816? Yeah. Oof, that doesn't look fun, does it? 361 fourths. Let's put it in black. 361 fourths. Now let's take the square root of both sides. N minus 9 halves squared equals plus or minus rad 361 over 4. This equals n minus 9 halves. Oh, we don't need the parentheses. Did I put parentheses in there? No, I didn't. That was weird. Good, equals plus or minus rad 361 over rad 4, which is n minus 9 halves equals plus or minus, well, rad 4 is 2. Rad 361, yikes. 361. I'm having a hard time even finding a number that goes into that. 3 doesn't go into it, 9 doesn't go into it. What produces a 1? 7? 21, so 361, I'm going to divide by 7. That's 5 is 35. That makes 11. Nope, 7 doesn't do it. Ooh, 361. Is that the answer? Does it end up being rad 361? What number is this? 18. 18. 18? Well, maybe 361 is a perfect square. 361 is a perfect square. 361 square root. 1981. I would have eventually gotten to 9, maybe. What did we say, 19? 19. 19. There's a new square root. That one I do not. I can't tell you when I have ever seen 361. That is so foreign to me. That square root. That is one of the most unlikely, which should be used more often. Plus or minus 19 halves. Wow. Not often you can wow Mr. Mac, but that was a wow. That was definitely, I was surprised by that one. That is 28 over 2, which is 14. And this is negative 10 over 2, which is negative 5. Hence those two nice, lovely whole numbers. Did we get negative 5, 14 on the one before also? Negative 5 and 12. Okay. Negative 5, 14. You learned something. 361, keep that on your radar. Math teachers and math programs like to give you things that you're not completely familiar with. 144, easy. 36, easy. 361, well, that's crazy. 361. 361 divided by 9. Yeah, what? How does 360? Did I do it wrong? 361 square root. Oh, 19, not 9. Hello. I'm like, hold on. 9 doesn't go into 361 because it's not 9, it's 19. That's what baffled me. I would have never have gotten 19. That's a good one. I'm still in awe of that. Okay. We're still completing the square. So we need our n, our a, to be positive. And I'll come up. Plus 20n. So you get n squared plus 20n equals negative 91. So we have our constant on the right. We have our ax squared plus bx on the left. We're going to take half of 20. Oh no, I don't want to do it in blue. We'll take half of 20 and square it, which is 100. So we'll add 100 to both sides, add 100 to both sides. That gives me n plus 10 quantity squared equals 9. Oh, that's nice. Square root n plus 10 quantity squared equals plus or minus rad 9. N plus 10 plus or minus 3 minus 10 minus 10. We get n equals negative 10 plus or minus 3. Negative 10 plus 3, negative 10 minus 3, that is negative 7, that is negative 13. In numerical order, it would be that answer. Oh, nice, yeah. We've already got it in that form. So b squared plus 12b equals 85. We're going to take half of 12 and square it, 36. We're going to add 36 to both sides. We get b plus 6 quantity squared equals 121 square root b plus 6 equals plus or minus 11. Those are ones that we recognize. B equals negative 6 plus or minus 11. We get negative 6 plus 11, negative 6 minus 11. That is going to give me 5. This is negative 17, and 5. What's going on here? Those were relatively simple. Nice. Okay, let's, did I make a boo-boo? No, A is 1. So here, we can factor out a 3, or we can divide everything by 3. Divide everything by 3, and you get n squared plus 2n minus 1 equals 0, because my A needs to be 1. That 3 is dividing all the 3 things. Now I'm going to move my constant over. So you get n squared plus 2n equals 1. Let's take half of my b value and square it. So we will add 1 to both sides. And that gives us n plus 1 quantity squared equals 2. We will take the square root of both sides. Not 2, Mr. Mac, 1. Plus or minus rad 2. That gets n plus 1 equals plus or minus rad 2. That can't be simplified. We will subtract 1, and we get n equals negative 1 plus or minus rad 2, and that is our answer. We cannot simplify that any further. We wouldn't put in a decimal value. 2 square root gives us an irrational number. I can never write that number down because it never stops and it never repeats. So that would, any number, any decimal value that you write is an approximation. I like exact. Rad 2 is an exact value. I'm going to divide by 2. Divide by 2. You get x squared minus 2x minus 3 equals 0. Let's add the 3 over. X squared minus 2x equals 3. Negative 2 divided by 2 is negative 1. Quantity squared is 1. So we will add 1 to both sides. This produces x minus 1 quantity squared equals 4. We'll take the square root of both sides. Plus or minus rad 4. X minus 1 equals plus or minus 2. Add 1, add 1. We get x equals 1 plus or minus 2. 1 plus 2, 1 minus 2, 3, negative 1, negative 1, 3 are my solutions. Now you must use the quadratic formula. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Remember, I told you in class today that this is called the discriminant. There are things that we can figure out, not part of this part, but later on, this is a question that tells you how many intercepts are there by the discriminant. So we know that the discriminant has to be greater than or equal to 0. Because if we get a negative number as a discriminant, we can't take the square root of a negative number. So something to consider. In this problem, my A is 1, my B is 0, and my C is negative 1. Why is that the case? Because remember, this is in ax squared plus bx plus c. And so this is x squared plus 0x minus 1 equals 0. So technically, my A value is the coefficient of x squared. My B value is the coefficient of x. And my C value is going to be my constant. So since there was no x in the original problem, we know that we have 0 of them. Hence why we don't see any. So x equals the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Ooh! Kind of just wanted to move those over just so they were out of the way, and I almost created a fiasco. 0 plus or minus 0 plus 4 all over 2. Come on down. X equals 0 plus or minus square root of 4 over 2. X equals 0 plus or minus 2 over 2. So we get two statements. We get 0 plus 2 over 2, and we get 0 minus 2 over 2. That's 2 over 2, which equals 1. This is negative 2 over 2, which equals negative 1. So my solution is going to be negative 1, positive 1, or plus or minus 1. I don't mind either way. A equals 1, B equals 2, C equals negative 15. And this is M, so we could say M equals whatever the variable is. Opposite of B, plus or minus square root of B squared minus 4 times A times C all over 2A. Negative 2 plus or minus square root of 4 plus 60 all over 2. M equals negative 2 plus or minus square root of 64 over 2. M equals negative 2 plus or minus 8 over 2. So let's separate them. Negative 2 plus 8 over 2, negative 2 minus 8 over 2. That gives us 6 over 2, which equals 3. This gives us negative 10 over 2, which is negative 5. My solutions are negative 5 and 3. Ooh, let's set it equal to 0. Let's push everything to the left. So that's n squared. My n's cancel out, and I'm left with negative 9 equals 0. We should already know what the answer is just by looking at that difference of squares, conjugates. But we'll keep doing it because we are told that we have to use the quadratic formula. So I'm going to look for your work. N equals the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. N equals 0 plus or minus 0 plus 36 all over 2. N equals 0 plus or minus square root of 36 over 2, n equals 0 plus or minus 6 over 2. Let's do the two statements, 0 plus 6 over 2 and 0 minus 6 over 2. 6 over 2 equals 3, negative 6 over 2 equals negative 3. So my solution is negative 3, positive 3, or plus or minus 3. Oh, wow. Yep, we're going to move it to the left. 3v squared minus 5v minus 5v plus 2 plus 2. We get v, that's 5v squared plus v plus 5 equals 0. Let's check it, make sure. That was a little fun. So a equals 5, b equals 1, c equals 5. V equals the opposite of b, plus or minus b squared minus 4ac all over 2a, negative 1 plus or minus 1 minus 100 over 10. We already see what's going to happen here. V equals negative 1 plus or minus square root of negative 99 over 10. At that point, we should recognize that we are taking the square root of a negative number, and the answer is going to be no solution. Okay, so be aware of that. A is 4, B is 0, C is negative 3. K equals the opposite of B, plus or minus square root of B squared minus 4 times A times C all over 2A. Negative 0. K equals negative, don't get lazy just because you're getting to the tail end of this. 0 plus, what's that, 48? 64. 48 over 8. Right? I think that's 12 times 4, yeah. So K equals negative 0, we'll just do 0, plus or minus square root of 48 over 8. Well, yeah, let's simplify. You can simplify now, it's probably better. So we know 16, hello, 16, no, 16, yeah, 16 rad 3 over 8. So it equals 0 plus or minus 4 rad 3 over 8. And now we can separate it. We get 0 plus 4 rad 3 over 8, 0 minus 4 rad 3 over 8. That gives us 4 rad 3 over 8. Outsides can cancel. You're left with rad 3 over 2. This is negative 4 rad 3 over 8. The outsides cancel to negative rad 3 over 2. So our answer is negative rad 3 over 2, positive rad 3 over 2. Or you can write this plus or minus rad 3 over 2. Oh, look at that fancy problem. We're okay here. A equals 2, B equals 4, C equals negative 8. M equals the opposite of B, plus or minus square root of B squared minus 4 times A times C all over 2A. M equals negative 4 plus or minus 16 plus 64 over 4. M equals negative 4 plus or minus, what's that, 80 over 4. M equals negative 4 plus or minus, I think 16 times 5, right? 16 times 5 over 4. M equals negative 4 plus or minus 4 rad 5 over 4. And yeah, you can separate it. It's going to be very interesting. Plus 4 rad 5 over 4 negative 4 minus 4 rad 5 over 4. You can't combine those numerators. Those are unlike terms. Negative 4 plus 4 rad 5 does not make just 0 rad 5. Nope, those are unlike terms. This has a radical, the other one doesn't, but you can reduce it. You can look at it as negative 4 over 4 plus 4 rad 5 over 4. That becomes negative 1. The 4's cancel. They can divide cancel. So you get plus rad 5. That's one solution. And then you can make this negative 4 over 4 minus 4 rad 5 over 4. And that makes negative 1 minus rad 5. So those are your two solutions. Your order, I have no idea. I would assume that it would be in that order. But it's a whole lot easier to just write this. Negative 1 plus or minus rad 5 is acceptable. Oh, that's it. Let's go. All right. Nice job. Good luck. Have fun with all this. You'll do well on the test. There will be no solutions on the test, so don't worry about no solutions, but you should know it. Good luck.